cool plasma effect. Put in half frequency. This was real soft, fine Litz wire. Sort of see. I was hoping that would make a difference, but the way I've got this now, it will work alright from 15 volts. So got it at 15 volts. Still get a pretty damn good field for a coil that size, but can draw out a little plasma flame now. See, it pulls 2 amps. That's the downside. Here's an IRF Z44N. I just happened to find it, and I would imagine this would have a much easier time driving this at lower voltage. The problem is, once you get up to higher voltage, I'm pretty sure that thing's going to pop no problem. But it does run much better at the lower voltage. So now I'm at about 13 volts. I can bring it down to about 12 volts. And it does pull about an amp at 12 volts. But you see, you still get little breakout there. You don't have the super beefy arc. This right here doesn't really pull up the supply. But I'm not sure how high I could crank it before popping that particular fit. That's a lower voltage. So the IRF Z44N popped at about 16 volts, pulling a arc off the top here. So now I've got a IRF P250N on here. I haven't changed out the capacitors. I have this one on at 12 volts. You see, it pulls close to a couple amps at 12 volts. But it does work, and you do get the little baby breakout. Once again, I'm still not pulling crazy arcs like I was before, but this is just all around a more reasonable setup. If one wanted like a tiny coil. So I would probably end up having to try to get a breakout closer to, like, if I was to cut it up, something like that I would probably have to deal with, with breakouts that aren't too crazy, because this way I'm not going to have to worry about destroying the coil or the MOSFET, running it too long. At 20 volts now, cut it on, and you see immediately when I get it in tune, it's pulling 3 amps. It's got that little breakout. I haven't adjusted the primary perfectly yet, but you can see now you're pulling bigger arcs. It's still not pumping the crazy juice that it was before. And before, I was pulling damn near mini flyback arcs. I mean, them things was white hot. Even though it still worked, I decided to give up on this coil I wound, because as you can see, I'd rather just wind a new one. But you can also sort of see that, say, a good portion of these windings are not really there anymore. So you could reduce this down. So I'm thinking about maybe taking this upper portion of wire and rewinding that, and see how small of a damn coil I can get. I'm going to have to drop the diameter down, but just to see. Like I say, I mean, this thing still pretty much worked. Another little micro coil. About 11 megahertz. Needs this exact precise primary location, and I have to get it oscillating first and back the pot back down to get the best tuning on it. Still works. So if I cut it up, get it going, then back it all the way down. Let's see. Put it about 24 volts. Actually off tune again. and bump it up to about 30. You don't get the crazy arcs that you can pull off of it, but you do get a pretty good feel. This tiny little guy right there. But yeah, way too high in the megahertz for this arrangement. We're on this coil with some pretty thin wire from a relay coil. But yeah, this is what it looks like before I tape it up. .15 volts, where I'm going to put it at 15 volts. Still get a pretty good feel, very low power draw. The arc isn't all that impressive, but can pull one. But yeah, also the voltage is high enough, whereas with a lot of the other ones it wasn't. But voltage is high enough, it gets in resonance enough at this frequency to light up bulbs and stuff like this. Put it at about 24. Get the nice little plasma deal again. See, we're at an amp. Go ahead and cut it all the way up. See, it cuts out at a certain point based on the tuning. I gotta tune that pot, but pulls a good amount of juice. But 24 volts ain't bad. It needs to be a little lower. As you can see, it's all about the pot tuning. Still not as beefy as they were before, but see, this one was going at about 3.6 megahertz. Now, just to show, same pretty much setup, but with a tighter coupling where primary feedback is sort of snug against the secondary. Basically outputs more power, which makes more sense, but I'll show that 25 volt. So you can see that's just at 25 volts, and I'm pulling the hot arcs like I was before, so I can only imagine at 30 volts be pretty beefy. So what have I learned here? Yeah, that will work, but if I was to try to run that like that for any period of minutes, what's going to happen is this plastic former is going to start deforming and melting right there where the primary is. Crack this damn bulb just holding it up to it like this, so it's no longer a partial vacuum. But it's only at about 13 volts I was doing that. After a couple seconds it just went crack. There's more 15 volts. Put that on. Now it still pulls about an amp. It's a little arc I get. But this bulb is going to crack for long doing that. This one probably cracked too. Ow, that's hot. Whew. This is kind of interesting. See, I got this little guy coming off the top load, 31 volts. Oh, what just happened there? Glass just broke, and yeah, that bulb just cracked. Damn, let's try this one. Interesting. Got the setup where the phasing has a low current draw at 30 volts, about 100 milliamps. This bulb, this old style, vintage style, doesn't have a plasma glow inside, but the filament starts glowing. Alright, so this particular coil ended up working like how I had it at first, which I thought had a diameter about this right here, but that coil is a little bit wider. And I've got that actually on a glass former, so that's not going to deform, but I've already had arcing from the primary over to these windings, and it probably took out about 20 or 30 turns. I'm fairly sure those are shorted together, but it still works. So the way this is set up, put it on, and it's running at about 200 milliamps. Hot arc. I haven't tuned the primary, so I can't really get a sustained breakout. See, it wants to a little bit. There we go. This guy, I wanted to keep him because I just like the coil, and I just left him on this test circuit. I'm gonna run it about 20 volts. And let's see, cut it up. And use this. About 20 volts. Pull little arcs. Have to draw. And cut it up. A little under an amp. I'd say a little over 500 milliamps. Just pull the cool little arcs. Breakout, top load, 22 volts, cut it up. It's getting hot. What about 60 watts doing that? Here's this guy. I really didn't have the proper components to condense it down smaller than that. Plus, if I was to do that, just the max output wouldn't be as impressive. It just sort of defeats the purpose. I mean, I can build a smaller Slayer exciter if it's not going to have a crazy output. But so you can see, I've got sort of a small heatsink for roughly potentially 90 watts this thing can pull at times, with, you know, I would say roughly at least at that voltage probably 30 watts of that is just straight dissipation. So you know, with this type of setup, it's not the most efficient, but it still works. So I'm going to put this one at 15 volts. So yeah, it's going now. And 15 volts. Get a little breakout. That's cool. That's not a bad little tiny arc you can pull. this is what it's pulling at about 15 volts, about 500 milliamps. And if I crank it up, let's crank it to about 24 volts. You can see now it's pulling a little over 24 watts now. And of course you can pull beefier arcs. So that's pretty cool. That's what I like. I mean, I can't do this with a Slayer exciter. One thing I had trouble with was this little. I was using this little guy right here. This is about 20 nanofarad as the series capacitor on the feedback winding, and that ended up basically shorting out. It just couldn't take it. So I ended up using those two little paralleled up 1 kV decoupling capacitors, and I just happen to use those on the other builds also. So I mean, I know it works, but yeah, I couldn't figure out what the problem was. I kept changing stuff out, and I was like, man, what is it? And it turned out to be that little capacitor there. So I don't know. I've got a slightly larger one on a different circuit that works alright, but this one just crapped out. Like, 15 or so volts there is a pretty good deal. But then you're dealing with like, 7.5, 8 watts, which pulls up closer to about 15 watts when you pull the tiny little arcs. But I mean, that's useful because it's a high frequency, beefy little arc that you can. I mean, it will set stuff on fire, no problem. Like I said, if you wanted to, you could crank it up to about 30 volts or higher. Obviously, over 30 volts or so, I'm going to need a bigger heat sink, but I still need to put a fan on here. So the idea would be something like put in a little container, make sure there's a fan on it, and you can pop out the top of this little guy. And like I say, the field isn't amazing. It's all right for a little guy like that, but for me, the whole point was to get something this small that I could, draw little arcs from like this. And typically with a Slayer exciter type circuit, keeping it as simple and low power as possible, can't really pull arcs like that. I mean, you're just, it doesn't really change the output a whole lot. You can light stuff on fire, but you're not going to get the hot little arc that you can. And this right here will get some metal red hot, if you sustain it, whereas a lot of other high frequency circuits like that just aren't going to do it. Plus, this is the true air core, and I have this one right around 5 megahertz. It's about what this circuit was meant for. So that's why I use this guy. And I have seen smaller nano deals that get little breakouts like that at high frequency for a much smaller package. But as far as I know, they're not able to go up in higher voltage and really crank out the hot beefy arcs. Just a lot of those other circuits, you can't do something like, draw out little hot arcs like that at like 20 volts or so, about 20 watts. But like I say, the downside, you can't do it for long, but you can do it. So that's really the whole thing for me. Wow, we really wouldn't want to go smaller than that. A lot of ways to go smaller than that, just to light up tubes and stuff. But yeah, I mean that's pretty cool. It's not bad. I mean, good little deal for what it is as far as like the micro coils go.